Hello, my name is Avani and my registration number is 19BCE1058. So let's begin with Project 1. The basic overview of Project 1 is like a typical computer architecture is based on a set of elementary logic gates like AND, OR, MUX, etc. as well as their bitwise versions like AND 16, OR 16, MUX 16, etc. That is assuming a 16-bit machine. This project engages you in the construction of a typical set of basic logic gates. This gates forms the basic elementary building blocks from which more complex chips will be later constructed. So let's begin with our first basic gate, that is AND gate. The AND logic function output is only true when all of its inputs are true, otherwise the output is false. So let's see, we have opened our hardware simulator. Now let's load chip for AND gate. So let's browse. So we will open nand2tetris folder. In nand2tetris, we will go to project. From here, we will load our HDL file, that is n.hdl, and we will load the script, that is nand.tst file. So we can see this is our HDL file, this is our script, and this input pin, output pin and internal pins are the current values in the pins. Okay, so let's run the code. Now let's see the output in the view option, and we can see when both the inputs are 1, our output is 1, and when both the inputs are 0, our output is 0. But when we have 0 and 1, since they both are different, so we are getting 0 as our output. So this was about AND gate. Now let's see AND 16-bit gate. So we will load AND16.hdl. So we have loaded, and now we will load AND16.tst file. Now let's run this. Now we can see the output. So this is for the 16-bit AND gate. Now let's move on to the next gate, that is OR gate. The OR logic function output is only true if one or more of its output are true, otherwise the output is false. So let's load or.hdl and load our script file, that is or.tst file, and let's run the code. Now we are seeing the output, so let's click on the output and we can see that 1 or 1 is 1, 1 or 0 is also 1, 0 or 1 is also 1, and 0 or 0 is 0. So this verifies the truth table of the OR gate. Now let's see OR 8-way, means 8-bit OR gate. So we will load OR 8-way HDL file and OR 8-way.tst file, and let's run this. Now we can see the output. So we are getting in and out for the 8-bit OR gate. Now let's see OR 16, that is 16-bit OR gate. So we will load our HDL file script file, that is or16.tst, and let's run this. Let's see what's the output is coming. So in view, we will go to output and we can see the output for the 16-bit OR gate. Now let's move on to the next gate, that is NOT gate. So the logic NOT function output is true when its single input is false and false when its single input is true. So let's load our nand2tetris file and nand2tetris file, and let's load the script and let's run the code. Let's see what the output is coming after the evaluation of the code. So we can see it's 0, then 1, and 1, then 0. So this verifies the truth table for the NOT gate. Let's see 16-bit NOT gate. So we'll load nand16.html file. Then we will load nand16.tst file and let's run the code. And now let's view the output. So we are getting in and out for the 16-bit NOT gate. We can see all the digits are reversed as 0 has changed to 1, 0 has changed to 1, 0 has changed to 1, 0 has changed to 1 here, 0 to 1, 1 to 0. So this was all about NOT gate. Let's move on to XOR gate. An XOR gate implements an exclusive OR, that is, a true output results if one and only one of the inputs to the gate is true. If both the inputs are false or both the inputs are true, a false output is come as the result. So let's load xor.html file and xor.tst file, and let's run our code. So now let's see what the output is coming. See, 0 and 0 are 0. So when the likely input, the output is true, and when the unlikely input, the output is false. So this was about the XOR gate. Now let's move to the multiplexer, that is MUX. Multiplexer is a combinational circuit that has maximum of 2 raised to n data inputs, where n selection lines and a single output line. One of these data inputs will be connected to the output based on the values of selection lines. So each combination will select only one data input, multiplexer. So let's see multiplexer. So we will load mux.html, and in a script we will load mux.tst. So we have loaded the script, and let's click on the run. And now we'll see the output, what output is coming. So this is the output of the MUX. Now if we want to see 16-bit multiplexer, then what will be the output? Let's see. So we'll load mux16.html and mux16.tst file, and let's run the code. So now we can see our output, and this is the output for the 16-bit multiplexer, where A and B are the input, 0 and this column is for selection line and this is for output. So this was about MUX 16. Now let's see MUX 4-way 16, that is 16-bit 4-way MUX. So we will load MUX 4-way 16, and in script we will load mux 4-way 16.tst, and let's run the code. And now we can see the output. So this was the output for 4-way Mux 16, where 4 inputs are there. Now let's see if Mux 8-way 16 was there, what will be the output? So Mux 8-way 16.hdl, then Mux 8-way 16.tst, and we can see our HDL file, that is the chip part and the script part, both are loaded. So let's run the code. These are the pin values which are changing after each line is getting executed line by line. So now let's see the output. And we can see the output for the 16-bit Mux 8-way 16. Now let's move to the next, that is demux. Demux or demultiplexer is a device that takes a single input line and routes it to one of several digit output lines. A demux of 2 power n output has n select lines which are used to select which output line is to send the input, and it can also be used to implement general purpose logic. So let's load our demux.hdl and a script that will be demux.tst file. So we can see this is our HDL file, this is our script file, that is .tst. These three are the pin values. Now let's run the code. And now we will see the output. So it is input selection lines and the output as A and B. So this was all about demux. Now let's see demux 4-way. So we will load demux 4-way.hdl, demux 4-way.tst file, and now we will run our code. As you can see, a demultiplexer is also called a starter distributor. So I think our code is completely run, executed. Let's see the output. So this was the output for our demux 4-way. Now we will go and learn our last code in the project 1, that is demux 8-way. So we have loaded demux 8-way.hdl file, and now we will load demux 8-way.tst file, and we can see this is our internal, external, that is input, output and internal pins. Now let's run the code. So we can see pin values are changing as we are getting to the next line. The pin changes can be seen in our pin values. So now let's see the output, and we can see that this is the output for the 8-bit demultiplexer, that is demux 8-way. So friends, this was all about project 1. So thank you.